Okay, this is logs day 2. And to begin with, we talked about 5 to the x equals 8. And I'm just showing the kids now what the answer was. You need to be good at this. Like, not just like, oh, I can barely handle this. You need to be good at going back and forth between exponentials and logs. That was day 1. So let's get good at that first. So this would be log base. Now, if you think about which one of these is a base, you just look at this. Only one of those 3 things is actually a base. It's the 5. The 5 is the base, and that means this should be a base. Now, if you're typing it in to get it, you couldn't use a subscript, but you'd have log 5. And then we usually put the argument in parentheses. You don't have to, but it's good because it separates it from the base. Now, for this part, you have to jump to the other side. If you remember, you have to go back and forth on these. So we go to the swing to the right, pick up the 8, and then equals, swing back to the other side, x, and that's what we were looking for changing it. All right, I want to do one more. I'm not doing the get it version of this. Just everybody on your notes, would you please answer this one? Log base m of p equals q. That can be rewritten as an exponential. How would you write that as an exponential? Like something to the something power is equal to something else. This one, I'd like you to turn it my way, and I'll tell you if you're doing it right. Yep. 4 people right. 5, 6, 7. Okay. Need to learn this stuff. Watch the video. Yes. 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 All right, good. Good. Almost everybody seems to be able to do it that other way. And that other way is, what's the base in this? Well, the base is kind of like a number that's lower down than the other numbers. Well, this one is the base. That's where you find your bases in logs. So m, and then to what power? You got to jump to the other side, to the q, equals jump back over here, p. All right. Now, you're going to learn a lot about logs today. A lot. Logs are a whole different thing than normal equations. They are a completely different rules. Like multiplies can turn into adds. Like divides can turn into subtracts. So I'll give you an example of that. Log base 2 of 20. I think all of you know that 20 is 5 times 4, right? So I can change this 20 into a 5 times 4. Then what you wouldn't expect is that you can break this log question into 2 parts. You can do log base 2 of 5, and then you can do log base 2 of 4. And wouldn't you expect that you would multiply them together then? Because, I mean, 5 times 4 is being multiplied. But you actually add them. This is a property of logs, that you can take up something that has been multiplied and split it up into the 5 and the 4 separately. They're here and here. Except this multiply turns into an add. Now take a wild guess what happens when I change this into 5 divided by 4. If the problem had a 5 over a 4, it would still have a log 5, and it'd still have a log 4. And what do you think I'm changing that to? Subtract. All right. Now I know this is just a couple facts, and it's hard to just memorize these things, but there are going to be a lot of little things we're going to teach you about logs. This is a list. In fact, I'm going to ask you to take a screenshot of this. Let's take a quick screenshot. That'll throw it into your notes. Because these are 4 of the most important properties that you are going to need to know. This is that one about multiplying them. Thank you very much. Turning into adding. This is that kind about dividing them. Turning into subtracting. Here's 2 more. What this one is saying is that if there's ever a power on the argument, that you can move it down into the front. This is exactly the same as the other one, except the p has moved from the power down into the front of it as a multiply. Again, not something that would work in normal math, but in logs it does. So here's an example of one. Log base 2 of 8 to a power of x. You could put the x in front and then still have the log base 2 of 8. So powers can come down off of the argument and go to the front of the problem. And the last one is really one that just kind of like logically makes sense. Look at it. It says if log base b of m is equal to log base b of n, then m and n must be the same thing. In other words, if I had, here's the simplest of them all, log base 2 of 1 is equal to log base 2 of x. Well, then, of course, log base 2 of 1 is log base 2 of, what's x gotta be? 1. So that this will be identical to this, right? So you can tell that x equals 1. In this problem, it's a little more complicated, but this is log base 8 of a whole bunch of stuff is equal to log base 8 of a bunch of other stuff. Well, then that means this stuff has to equal that stuff. So the way I like to think of that is that those base, if they have the same base, they can cancel. You remember that rule? Remember when we had like 2 to the x equals, 2 to the 5? That if these are the same, then the answer is these are equal. It's kind of like those 2's canceled. Do you remember that? It's like that. Log base 5 of x equals log base 5 of x minus 4. Actually, let's not do x minus 4. Let's just say 2x plus 5. Okay. Then, since this is the same as this, it's like you can cancel them. Again, it's not really canceling. It's just saying those don't need to be there. I can just use the x equaling 2x plus 5. Do you get that? It's sort of like I just canceled off these, but it's not really canceling off those. Okay? Okay. So then we could solve this equation and subtract x from both sides and then subtract 5, and then you'd have your answer, x equals negative 5. All right, now actually that would be illegal because you can't have negatives in the argument, but I made up that problem really quick just to show you an example. All right, let's do another. Use properties of logs to condense the following. Oh my, where did that come from? We didn't have that oh, they must have just changed this smartboard like last hour. So, all right, I can roll with this. If you take a look at this problem right here, you know, we're not ready for condensing today. I'm not gonna do that condensing problem yet. You're not ready for that. You're just learning logs. So, all right, log base a of 1 equals, I don't know what. I'm gonna put a question mark there. I would rewrite that as a to the question mark equals 1. And now just think about it. I don't need you to memorize this. After a while, some of you are going to get quick at this. You're going to notice that every time there's a 1 there, a certain thing happens. But just rewrite it. That to the that equals that. A to the I don't know equals 1. What's the question mark got to be? 0. Very good. And what's surprising about this is that it doesn't matter about anything else. If this is a 1, then your answer is automatically 0. It has to be. Think about it. If you take, no matter what this is, if you put it to the 0 power, it will be 1. Get what I'm saying? So if there is a 1 in the argument, you'll get a 0. So I have a dumb little saying that helps me remember this. You don't have to memorize this because you can just put x and solve it. A to the x equals 1 and go, oh yeah, x equals 0. But if you want to memorize it, if you won the argument, remember, that's the argument spot. If you won the argument, you get nothing. It's true in logs, and it's true in life, too. If you win the argument with your friend, but you, like, create an enemy out of your friend, then you got nothing out of that. That was stupid to win the argument at all costs. Okay? So if I won the argument, you get nothing. So I'll give you an example of that. Log base 2.573 of 1 equals, and then boom, I know the answer. What is it? 0. Because if there's a 1 in the argument spot, the answer is going to be 0. Could I force it to be solved and go that to the power of 0 equals 1? Yeah, that proves that it's got to be 0. All right. The hand that it was up is gone, so I'm going to go back, keep going here. Try these. You don't know what the answer is, you can put, and now there's already x in the problem. So you can put a question mark if you want, because that might be like less confusing than having another x in the problem. Do you get this means a to the I don't know what equals a to the x? A to the I don't know what equals a to the x. And now if the bases are the same, that has to equal x, and so the question mark must be x. You're right. What's the moral of the story here? The pattern you will notice, again, you can always solve these by rewriting, but the pattern you will notice is that if these two are the same, that's the answer. The answer is x. So if I move this over, there's supposed to be an x underneath there. Okay. Let me show you that again in a different way. Log base 3 of 3 to the 3rd power. No, that's really dumb because they're all 3s. 3 to the 7th power. There we go. Without having to rewrite this, what's the answer? 7. You could rewrite it by saying, I don't know what this is. 3 to the I don't know what it is equal to 3 to the 7, and then you just look at it and go, oh, well, duh, the question mark must be 7. Okay, so you can solve these by rewriting them like this. And if you want to put an x, there wasn't any x's in this problem already, so I could put an x here and then say 3 to the x. And then, oh, ones are the same. X equals 7. All right. Wait, is there one more property on this page? This is the weirdest looking one. It's got a power that has a log in it. It really makes it look complicated. A to the log base a. I'm going to show you a problem. 4 to the power of log base 4 of x. I'll give you a hint. Here, when these two are a, the answer is x. Take a guess. What's the answer to this one? X. Because if these two are the same, that one turns out to be the answer. So yes, the answer to this is x. And there should be an x there. Can't explain why the answers are all missing today. All right. So if I have, could I prove this? Watch me prove it. 4 is the base. That means this could be rewritten. This actually isn't a log. There's a log in it, but this is an exponential. So I could rewrite it as a log. I'm just proving, you don't have to like do all of this yourself today, but I'm proving to you this actually works. If this isn't a log, I can make it a log, and its base would be 4. And then I jump to the other side of x, log base 4 of x equals, and then I jump back over here. Look at that, log base 4 of x. If that's equal to that, then it must have been true. All right. This is a classic example of if you weren't here on Friday, it'd probably be confusing right now, and then that would be confusing for anybody. That's a bizarre one. But let me just show you another example. I think you'll catch on to the pattern. It's really easy. What's the answer to that one? 7. That's it. Done. No big deal. These two are the same. That's the answer. There's another one like that. It's a little different. Log base 8 of 8 to the 9th. What's the answer? 9. Can I prove it? Yeah, by saying equals x and then rewriting 8 to the x equals 8 to the 9th. And look at the bases are the same. X must be 9. So once you catch the pattern, though, it's no big deal. All right. Now here's on this note. Do you remember that I showed you another way to do this problem? This to the 9th power, in the first list of like 4 little properties, the third one was that if there's a power on the argument, it could go where? Out in front. This 9 could go out in front, and then it would be 9, and then it wouldn't be here anymore. Why, if I know the answer to this is supposed to be 9, because it's what the power was, how does this work? Take a guess what log base 8 of 8 is. What's it equal to? 1. if these two are the same, the answer is the power. Well, there's no power, but there is a power. It's a 1, right? So if the 8s are the same, then the power is the answer. So the answer to this whole thing in the box is it's equal to 1. So then it's 9 times the 1, which makes 9. So the original problem on this, again, was log base 8 of 8 to the 9th power. And then I made it into this. And then I said this part was equal to 1. So 9 times 1 is 9. The answer was 9. I could have got that just by looking at it and going, oh, 2 8s. The answer must be the power. All right. What's the answer? 12. These two are the same. That's the answer. All right. Now let's do a little bit of rewriting. Do you remember our original question we had on this was like 5 to the x equals 8. And we figured out that that was log base 5 of 8 equals x. But that, I said, we could put in the calculator and find. Do you remember how to put it in the calculator? Don't do it, but do you remember how to? It was log what? Yes? Log 8. Take the second one first. Divided by, talk to her later. Thank you. Log 5. Log 8 divided by log 5. Now, this is called change of base. Why? Because this had a base of 5. Do you get these other two that I just wrote? I didn't even have a base on them. Look, there's no number here. So they changed from a base 5 to a base. There is no base, but there is a base. Do you remember me saying that there was a base that was so common that you didn't even write it? It's kind of like square roots. The most common square roots like this. You know now that you could have been writing that with a little 2 there. Sorry. A little 2 there for a whole time, right? But it was the most common square root, so you don't even write the little squared. Same idea. The most common base on logs is base, what do you think? 10. Somebody knew it? Log base 10 is the most common base. So they call it the common log. And that means that if you don't write a base, you mean base 10. And take a wild guess what your calculator defaults to doing. Base what? Base 10. So if you're going to type this in the calculator, you just say log 8, and every log has a base. It's just a matter of if you don't type the base, it's assuming you mean base 10. So this was a base 5 problem, and I change it by doing this into a couple base 10s. And that way I can do it on the calculator. All right, everybody grab your calculator, type in log 8, divide by log 5. You'll have done a change of base question. Should have got a decimal. If we round to like 2 decimal places. Maddie, what'd you get? 1.29. All right. That means 5 to the 1.29 power should be about 8. Why isn't it exactly 8? Because when we say 1.29, we're rounding. So that's not going to be perfect, right? All right. Okay. That's a big review of what we learned before and a bunch of new stuff on logs. Now, there's a little bit more to learn, but not tons. If you understood what I was just telling you a second ago, then log base 3 of 3 to the x should be an easy one for you. It's just x. Boom. Now, this log base 9, or no, log base 3 of 9 to the x, boy, if that 9 was only a 3, it'd be so much easier. It could be. So let's say how to do that. I'm going to get rid of this 9, and you tell me to put in what instead? Yeah, 3 squared is the same thing as 9. You can do that, can't you? So then, take a guess what the answer is. 2x. That makes sense? That's the answer. because I just changed a 3 squared to a 9 to a 3 squared. Okay, 25 to the 1/3 power. Do you get the same thing as what that's the root 3. Do you get that's the same as saying 25 to the 1/3? 25 to the 1/3 is the same thing as this. I'm going to rather use that. Now, change that 25 to a 5 squared, because then this and this will have the same base. 25 becomes 5 squared. And now the answer, when you have a power to a power, you multiply those together. And if that is the same as that, the answer is that. 2 times 1/3, which would be 2/3. Do you get that one? I'm going kind of fast here. All right. The last one's a really simple one if you've learned the pattern. What's the answer on the last one? X, because if that's the same as that, the answer is just that. X. Okay. What's the answer to this one? 100. Cool. Done. That should be really rewritten as a 7 squared, and then it's the 4th root of that. Try it, please, and then tell me what you think the answer is. Again, you're going to want to rewrite that, and it'll say log base 7 of 7 to the something, and then once these are the same, the question mark will be your answer. So it's a fraction answer. Turn it my way, and I'll tell you if you got it right. Yep. Nope. The bottom part's right. Top part was wrong. Yes. Nope. Yes. Reduce that and you'll have it. Yes. All right, I'm getting about 3/4 of you have it. Now this would be one of those times where if I was more used to get it, the cool part is I'd be able to tell who hadn't answered yet. And if I would have just said, hey, type your answer in to get it. The only problem with it is I have to go create the question over here. But I'm going to try something called quick question. I'm going to hit quick question and then go short answer. There, I just sent one on to get it. Would you please go to get it? And it doesn't have a question. It's a blank question. What I'm asking for is the answer to the one I just did. You wrote it, you turned it my way. Just type it in there. Just give me an idea of how well this would work. And if you don't know, that's okay. Don't just copy somebody else's. Thanks for being honest. And the cool part is it'll show me who I know I'm kind of still waiting for. Okay. Let me show you what we do here. Would you agree the 49 can be replaced with a 7 squared? So then, you just have to be able to rewrite that as 7 to the, roots go on the bottom, 2/4. And therefore the answer is 2/4, but you really want to reduce that. And therefore your final answer, I'll send one out. There's the answer. Okay. Thank you. I'm getting better at using that. I'm brand new. Today's my first day ever of knowing how that works. So this is the last thing you need to know how to do for today. And the good part is you're going to have 10 minutes to work on homework, where my other classes so far didn't have any time to work on homework. So let's get through this quickly and you'll have some time. Log base 5 of 22. You expect me to do that in my head only to this level? Would you agree I could put an X here because there's no X in the problem yet? Would you agree then next I could rewrite it as 5 to the X equals 22? Now do you get that 5 to the first power would be too small? Would you agree that 5 to the second power, which would be 25, is too big? To get the answers between 1 and 2 then? We're trying to figure out x, right? So we know it's got to be, 1 would be too small, 5 to the 1 is 5. 2 would be too big, because it'd be 25. How about this? If you even wanted to get better at it, would you agree it's a lot closer to being 2 than it is to being 1? And therefore the answer's probably like 1.8-ish? Do you get how you can kind of do these in your head a little bit? Granted, a calculator would be able to tell you the exact answer. And you'd type in log 22 over log 5. Everybody try that. Log 22 over log 5. My guess was 1.8. Let's see how close I was. 1.92. Okay, so I was only off by 1/10 or 12 hundredths, which isn't too bad. That's pretty close. And I didn't cheat and know the answer ahead of time. So, okay. So log base 3 of 5, again, if I had a calculator, I'd type log 5 over log 3. But we don't, there's no calc section on the test, so don't cheat and use the calculator here. In your head, this is 3 to the x equals 5. What's it between? Between 1 and 2 again, because 3 to the 1 is too small, 3 to the 2 is too big, so it's between 1 and 2. Make sense? All right. You don't even have to get the decimal answer, but if you wanted to, this one's kind of like closer to the 1. I'd say it's like 1.4, because 1.5 would be exactly between the two, and I'm just saying it's a little less than that. What is it actually on a calculator with a decimal? 1.47, only off by 7 hundredths. That's not bad. So you can kind of estimate these pretty easily. All right, so this one, it's 2 to the x equals 9. 2 squared? No. 2 to the third? Too small, but close. 2 to the fourth? Too big. So it's between 3 and 4. The idea? All right. Then let's start your homework. Everybody find your homework. We did already do this stuff. This would just be log 8 over log 2. Remember, you already know how to do this part. This would be log 8 over log 10, log 15 over log 3. We are changing it to base 10. These are base 2s, but by rewriting them the way we are, they're changing to base 10s. And your assignment is right there, logarithms day 2. And I'm assigning less than normal because I spent some time at the beginning with get it. I'm giving you just the evens for tonight. So it's half as big as usual. And you do have about 10 minutes to work here. Okay, I'll start it with you. I'm going to pause for a second while I get the worksheet on the screen. Okay, so for instance, problem 1 in the whole doing evens thing, if you can't rewrite this by now, you're way behind. This would have been an easy one. You don't have to do it because it's an odd one and I assigned evens. But it'd be 1/4 to the power of x. Remember, you can always say equals x. To the power of x equals 1 over 64. And then you could do this without a calculator because these can have the same base. All right? So all it is a rewrite, and then it turns into one of the problems from your last test. Okay, but now let's do the evens. Can you do the evens of the evens? I guess yes, because especially number 2, it's kind of cruel because you get to skip number 1, which only had 2 parts, and then do number 2, which has like 17 parts. So we can do the even letters. What are the even letters? B, D, F, H. Okay, so you can do it this way. Skip all the odd ones. Skip every other one, right? Yeah, cool. All right. So let's do this first one. Notice it says no calc. Seems like scary because it's got this weird decimal, but if you know the pattern, easy peasy. What's the answer? Stay with me. What's the answer for this one? For B. Negative 0.23. Why? Because if these two are the same, that's the answer. Now, what if you hadn't been able to do that in your head? You forgot the pattern. Just say equals x. There's no x in the problem, so I can say equals x. Then say 2/3 to the x equals, and then you go back over here, 2/3 to the negative 0.23, and you go, wait a minute, bases are the same. Answer is x equals 0.23. See what I mean? So you don't have to have it memorized even. But it's faster if you have it memorized. It's a lot faster. Okay. Oh, this one's really easy then. What's D? 14 over 7, but what's that? 2. Okay. How about log base 8 of 7 to the 0? Ew. Oh, that's kind of cheating because 7 to the 0 is really what? And if you won the argument, you get nothing. The answer is 0. Now, could you have rewritten the equation and said 8 to the x equals 1, and then gone, gee, what could I put 8 to make it equal 1? Oh, the answer is 0. Yes. But if you learn the little pattern that if the argument is 1, you get nothing, that would have been faster. All right. On H, could you say an x here? Yes, there's no x in the problem. So 2 to the x equals 8. And then you solve it. Now, could you have done it in your head? Absolutely. What is the answer? 3, because 2 to the third is 8. And some kids are going to go, okay, I'm going to rewrite that 8 as a 2 to the third. And then I have 2, 2, and then the answer is 3. It's fine. You can do it that way, or you can set it equal to x. If you're not awesome at this, your happy place should be set them equal to x and rewrite them as exponent problems. All right. Then on the bottom part of this worksheet, it's the really easy part. It's just like tell what it's between. You know, like this first one, 4, yes, I'm going to say equals x. 4 to the x equals 5, and then I say, well, 4 to the first is too small, and then the next one's got to be too big. 4 to the second is 16. It's between 1 and 2, because it's between 4 and 16. Oh, expression in base 10, that just means how do I put this in the calculator? Log 5 over log 4. Now, because I'm having you do evens, I really would rather have you skip the even letters than to skip problems 1 and 3. You can skip number 1 because I told you you could, but what I'm adjusting for my directions here, just skip the even letters. So you may skip problem 1 and, oh, sorry, do even letters. Do the evens, skip the odds. Sorry. What that really means is on problem 3, you're going to do B. I can't tell, does the worksheet go lower than this, or is that it? Okay, yay. It's not shortish, which is always good. So, yeah, it's short enough. I probably didn't have to have you skip a whole bunch, but I do want to keep my commitment to keeping your assignments a reasonable size. Okay. And there's a lot more to learn about logs, but I have to say today was extra bad because we crammed in that whole set of extra log rules. It won't be that bad tomorrow. Tomorrow will be a more normal day. Have a great day.